Hi, and welcome to Software Design and Development, Testing, Lesson 5, Live Test Data. So when you test a new system during system testing, you need to test it using live test data. And what live test data is, it's actually real data. So it's not stuff you've randomly generated, it's real data that the system will handle. And where possible, you should be testing with actual data generated from the processes that will feed into the new system. So testing a piece of software alongside its counterpart if it's a replacing your system. Um, this is a really good idea. So you can actually see that it can do everything that it needs to with the real stuff that the company is using. So one of the things you need to test a program with is large file sizes. During testing, files will be quite small as they don't currently hold all the data that they should. And oftentimes the data will increase over years as the system holds more things. A system could run well with, for example, small database files, but could suffer performance issues when these files get bigger. Some of the issues can include running out of hard drive space or cloud space, since we store things in the cloud now. You can run out of RAM, so loading these big files might take all the RAM on a certain computer and not leave you anything for anything else. And performance issues relating to the time taken to read and write to large files. When you test, you need to make sure you use a mix of transaction types. So what happens normally is that you run multiple tests on one series of instructions, and so the system might pass perfectly. But the problem is that a user doesn't usually run 50 different iterations of the same process all day. They would do a whole stack of different things. Think about how you guys work. You check your email, you might open a Google Doc, work on one Google Doc, then check your email, open an iMovie, and so on. You do different things throughout the day. So the system needs to be able to handle all of that. And oftentimes errors can arise not in the running of processes, but in the switching between processes. Response times are really important too, and these need to be tested. Um, and something that might have been acceptable when it's tested can become unacceptable once used in real life situations. So issues that can increase response times are things like increasing file sizes. So as we spoke about databases before, these databases often get bigger as time goes on. If you guys think about the student database at school, we store information on every single student in our school. When a student graduates in year 12, we store their details in a file called alumni. And so obviously every year this file gets an extra 200 students in it from the next year 12 class. So if we use the same system for many years, it would have many students in it. Another thing you need to look at is other software running at the same time using system resources. So we test the software on a computer running by itself. We don't necessarily account for other software running at the same time. What you might find is an operation that a user needs to do will often require the use of two or more bits of software, your software being one of them. So they will need to switch between your software and another piece of software. They can't keep it shut. So obviously this would use system resources, and it would use system resources in the running and processing of the software, not just in the letting it run in the background. So these aren't necessarily always tested for, and they can't always be tested for, because it's difficult to know what the client will need to be running at a certain time. The last one would be the constant opening, reading, writing, and closing of files when switching processes. So if you run the last issue that arises is the constant opening, reading, writing, and closing of files when switching processes. When you run iterations of the same test, you don't necessarily open, read, write, and close the files every single time. When you're switching processes, it will happen, and if you switch between processes frequently, this time might take a long time. Test data should account for all of these areas to ensure the program will stand up to everyday use. Another thing you need to look at is the volume of data that a system can handle, or load testing. So a developer cannot foresee every use case for their software. The system may be designed for use by a 20-member team, and the use is greatly accepted, and the company decides to run it for 500 members. What worked for 20 isn't necessarily going to work for 500. You might need a different way of handling the data, for example. So what you do with your system is you need to test it for ever increasing amounts of data. So things such as large amounts of data and then large amounts of transactions or operations with your system. Okay? And at some point your software will fail. No software can just keep running forever. You will find a point at which it breaks. Okay? When it breaks, you record that point so that software so you know when software needs to be modified at a certain point. Okay. The other thing you need to look at is the effect of the new system on existing systems. So you're going to be installing a system into a set of currently existing systems. Most people, when they look at new systems, they consider hardware and they consider software. They may consider the data use in the system as well. However, most people don't really consider procedures and personnel. They're the two parts of a system that generally get left behind. So you know that when you install a new system, you need new hardware. Obviously, we're being software engineers, we develop new software. And in the development of software, you need to consider the data that's going to be used. However, you also need to take into consideration how this software will be used. So teaching people how to use it and developing procedures around the collection of data, the input of data, the process of data, the output of data. What happens with all of those? However, the last part, personnel, you need people to run your system. And you need to make sure that your system will fit in with what they do in the rest of their world. Your software isn't necessarily going to be the only piece of software they use all day. It's not necessarily going to be the only thing they need to do each day. So you need to make sure that your stuff will fit in with the rest of their stuff. Similarly, you'll affect all of these other 5 parts in other systems. So the hardware that you install, it may not play nice with hardware that's already there. The software that you install may conflict with another piece of software. The data that you install, that you use, may not be in the right format for another piece of software. Or maybe the data that you want to collect is in a different format from another system. The procedures that you develop may conflict with procedures that are already in use. And the personnel, they obviously won't know how to use the software, but you might be doing something that's totally against their way of thinking and something they wouldn't be able to think of normally. So you need to make sure you account for all of these and try to make it fit with as small amount of jump as possible. However, the problem is that you cannot fully plan for these things. You can look to the future and try to see where issues might happen, and that's really good practice. But the only time you'll know the full impact is when you actually put it into real people's hands. You put it into the organization that's going to run the system. You implement it and you see how people use it and where the problems are.